So welcome back to the channel guys. Hope you are doing extremely well and this is your very own mass coder this side. So in this video we are going to discuss lecture number 13 of the linked list series and we are going to discuss the question remove duplicates from sorted list. In previous lecture we saw about unsorted list and now it is time to see for the sorted list, right? So the question is exactly same, but in the previous question it was not necessary that the list was sorted, but it is necessary now. Okay, so what was the algorithm we used in the unsorted list case? We just keep an account of the already inserted elements, account of already inserted elements. Where do we inserted it? We used a map to insert the elements which are already part of our answer linked list, right? We used a map. Now it is anonymous. Okay, now it is axiomatic that if it is working for an unsorted list, if that code is working for an unsorted list, it will work for sorted as well. It will work for sorted as well, right? It will work for sorted as well. What was the time complexity? It was O of n was the time complexity and O of n was the space complexity, right? So it is encountered that we can solve the question in O of n time complexity, O of n space complexity. But somehow can we decrease this? I want to decrease the space complexity. Given that the list is sorted, I want to reduce the space complexity. How can I do it? How can I do it? So I will use the same algorithm. I will make a dummy node. Suppose -1 is here, right? This is my dummy node. I will make A here. I will keep my temp here, right? So previously we were actually comparing temp value with the map. We were comparing temp value with map. Now what I can do, because the list is sorted, the duplicates will occur together. Duplicates will occur together. I want to use this information to get my answer correct. Duplicates will occur together. So what will I do? I will say the last if the last inserted element if the last inserted element in answer linked list is matching current temp value, that means element is duplicate, otherwise the element is new, otherwise or else I can say the element is new. This is the only approach, because the list is sorted, so it is pretty evident that all the ones will occur together. It is not possible to insert a 2 here and then go for 1, right? Then it will not remain any more sorted. So 1 1 1, if there are 3 nodes of 1, they will occur all together, and out of these 3 I have only to take this one node. I have to take this one node in my answer, right? So given my linked list is 1 1 2 3 3 3 4 4 5 6 linked list. What I will do, I will first make a dummy node as -1, right? I will name it as dummy. I will use a for traversal of the dummy node, that is the answer linked list. Keep a temp here. Now what I will do is, I will say is this value, is this one equals to my a value. If temp value equals to a value. Why I am comparing with a value? Because a value is the last inserted value. In that case, element is duplicate. So what you will do, you will just skip it. That means temp will move forward and I have to delete this node. That is, I will say x equals to temp, right? Assign a x here. Temp equals to temp next. Temp equals to temp next. Temp will move here. And now delete your x. Delete x. Right? So this will delete this node. I will just rub it. So it is becoming something like this. Moving forward, I will say is temp equals to 1, right? Oh, sorry, that was not the case in the previous node, right? I just use it for example, right? Else, it is else node, right? It is else node. So if that is not the case, if this if condition fails, then what do I do in else? I will say a is next equals to temp. Already discussed how we connect. So a is next equals to temp. A equals to a next. That is, move your a from here to here. That is, a comes here and no longer remains here, because this is my next node, right? Now temp will move to temp next for the next traversal. Temp equals to temp next. That is, temp will come here and no longer remain here. Now what I will do, I will just break this connection. Why I am breaking this connection? Because it facilitates my linked list forming at the case of AND. So I will say A is next equals to null, right? So this linked list will also break. Now moving forward, I will see this A is actually containing 1 and the temp is containing 1. So this case will work. This case will work and it will just create X here, temp here and delete this node. So it will be looking something like this. Moving forward, 2 not equals to A. So a new connection will be formed here. A will move here, temp will move here and I will break this connection, right? It is 1 here, right? Moving forward, temp equals to 2, no. So I will just make a new connection here. A will move here, temp will move here and connection will break. That is this with this and this. Moving forward, 3 equals to 3. So I will keep an X here, temp will come here and I will delete this node. So it will look something like this now. Moving forward, 3 equals to 3, X here, temp here and delete this node. So again 4 not equals to 3, so make a connection. A will move here, temp will move here, right, and delete the connection. That is A will move here, temp will move here and A delete the connection. Again 4 equals to 4, so X here, temp here and delete this node. So it will be looking something like this, right? Moving forward, 4 not equals to 5, so make a connection. A will move here, temp will move here, right? Now and after that break the connection also. So this connection is broken and this temp is here, right? Moving forward, I will see temp is not equal to A, so A will make a connection. A will move here, temp will move to null and I will make this as null, which is already null, right? So you can see my linked list is looking something like -1, 1, 2, 3, 4, 5, 6. This is my answer linked list. This should not be the answer part, right? This should not be the answer part. I have to remove this dummy node. Again simple, name it as X, my head will be dummies next and I will delete this node. So I am just doing X equals to dummy, head equals to next of dummy and delete X. Now your answer is stored in head. So return head, return head. What is the space complexity now? So the only optimization we done was to space complexity. Why? Because now we are not using any map to store the already occurred element for the duplicates, right? We are not using any map now. So this linked list approach is actually very optimized. It is using O of n time to get to the answer and O of 1 space complexity, right? I hope you understand that. I hope you understand that. Now it is time for you to please watch the code for it. Guys, so here we are in the coding section and it's time for you to show you the code. Before writing down the code, I would like to request you to please subscribe to my channel and hit the like button as much as possible, right? So let us move on. So what are the first steps? I will create a dummy node. So list node star dummy and let us make the value as new and make the value as -1. Why -1? -101, sorry, because it is being given to you that in the constraints you can check. In the constraints it has been mentioned that the value of a node can range between -100 to 100. So I'm taking a value just out of the range. Right now, I will make a node that will point to the dummy, that is A. A equals to dummy right now, and my temp will point to the head. Now simple traversal. So while temp is not equals to null, what will I do? If temp value equals to A value, what will you do? You will create a node X, list node star X equals to temp, list node star X equals to temp, the node which has to be deleted. Temp will move to temp next, right? And now you can delete your X, delete X. Else, what is the else case? That is, we have to insert the node. So A is next is equals to temp. Move your A forward, that is A equals to A next. Move your temp forward, that is temp equals to temp next. And now delete the nodes, that is, delete the connection. So A is next now becomes null, right? And after this while loop is completed, I just have to delete the first dummy node. So list node star X equals to list node star head equals to dummy next, and I can delete the dummy node. So delete dummy, and now your answer is head. This is head here and your answer is head. So return head. Hope it will work. Let us try to compile and run it. In the meantime, do consider subscribing to my channel and hit the like button as much as possible. So there has been a mistake. Oh, head has already been declared. It has been passed as an argument, so I don't want to re-declare it. Let us try it again. It should work now, I guess. It is working fine for the sample test cases. Let us try it for the hidden test cases as well. That is a submit button. Hope it will work. It is running fine. So thank you for watching, and we'll meet in the next lecture. So please stay tuned, and if you're not subscribed yet, do not forget to subscribe. Thank you. Have a nice day.